Hi, welcome to your course using Cobie for Facility Managers. On this week, we're going to talk about how to do a Cobie implementation plan. We're going to talk about an overview of the implementation plan. Well, an implementation plan is a framework that outlines the steps required to a successful implementation for the Cobie standard on a project. As we all know, Cobie is the industry standard format for exchanging building information between project stakeholders, including building owners, contractors, and facility managers. This implementation consists on 6 steps, which are as follows. The first one will be the planning. The second one will be data collection. The third one will be Cobie preparation. We're going to talk about these three for now, and on the next slide, we're going to talk about the rest. First of all, we have to plan on our implementation what is the scope of the project and determine the required data for the elements. Also identify the stakeholders and develop a project timeline. We have to make a schedule with a time frame of what time we're going to implement the Cobie standard. The next step will be to collect the data. Once we have all the requirements of the data, we start collecting the data and adding the information into the Cobie file. This information includes the building systems, equipment, components, information of the project, etc. The next step will be the Cobie preparation. How do we prepare the Cobie file? Well, we have to map the data that we collected in the step 2, and we have to organize the data and the elements created on the Cobie file. The next step will be the Cobie validation. Once we have all the data organized, we have to validate the information. This involves reviewing the file with the stakeholders and with all the workers involved on this data. And we have to ensure that this data is accurate and consistent. The next step will be the delivery of the Cobie file. We have to deliver this file to the appropriate stakeholders. This can be the building owners, the facility managers, contractors, and other interested parties. Then we have the step 6. The last step will be the Cobie maintenance. This will be a final step, and sometimes we can repeat this step once we have the file. We always have to maintain the information as accurate as possible. And this is done over the time. Well, this step involves updating the file and the changes that were made on the building systems, equipment, components, any element of the building. Overall, the Cobie implementation plan is a comprehensive framework for successfully implementing the Cobie standard in a construction project on any phase. By following these 6 steps, the project stakeholders can ensure that they can have a complete and accurate record of the building information, and this can be easily exchanged between all parties involved in the project. Well, now we're going to see a little video where this explains how you can organize the Cobie framework on the sheets. So let's play this video.
In this video, The basic structure of a Cobie. In this video, the basic structure of a Cobie file will be introduced. So we know that the contents of a Cobie file contain information about maintenance, operations, and asset management. The formal specification for the information to be delivered is found in the Cobie Model View definition. This is an ISO 16739 compliant specification for all of the objects in the IFC model needed to express Cobie. That set of information can be thought of as the contents of a letter. In this video, we're going to talk a little bit about the envelope, the formats in which Cobie is delivered. When someone talks about an IFC file, what they're generally talking about is a file of a format that looks like what's shown here. This is an ISO 10303 or STEP physical file model. Obviously, this is not a thing that a human is supposed to read. This is a file whose intention is direct system-to-system information exchange. But since a lot of the information that's contained in Cobie needs to be viewed by people, maybe this is not the best format for all of the uses of this important facility, asset, operations, and maintenance data. The Cobie spreadsheet was created as an equivalent presentation or equivalent envelope for exactly the same information that is found in a STEP file. So, the following slides will talk about the structure of Cobie in the context of the spreadsheet format of the Cobie data. Each of the yellow boxes in this diagram is a separate spreadsheet within the overall Cobie workbook. Notice that the information is organized into information provided by design, information that's provided by construction, and information that's shared in common. Let's start by looking at the design information. The first set of design information that's important to Cobie is the vertical and horizontal decomposition of the spaces within the building. So that's the facility, the floors, the spaces, and the zones. Here's the facility worksheet for the medical clinic project. You can download this project yourself by going to the Common BIM file page at the Building Smart Alliance website. Most Cobie files will only have one building, so if you have multiple buildings on a given project, you'll have multiple Cobie files. The one building per Cobie file rule is not hard and fast, but it's generally recommended. We did this to make sure that the rest of the Cobie data file would be as simple as possible. Within the building's envelope, there are floors where people live and work. On top of the building there's a roof, and there might also be equipment out on the site. So all of these different vertical levels of the building would be identified in the Cobie floor workspace. Very complicated buildings like labs and hospitals that have very large interstitial spaces might also have floors to model those interstitial spaces, separate from the modeling of the space underneath. Really, it depends on the specifics of the project and how the designer wants to organize the work. Either way, it's just fine with Cobie. The next spreadsheet is the Cobie Space Worksheet, and the Cobie Space Worksheet takes the rooms in the building and breaks them up into spaces which perform a specific function. The distinction between spaces and rooms is not all that important unless you have a very large room where several different kinds of things could take place. In that instance, you'll probably have the room number with a dash in A and a dash in B and a dash C or some other kind of designation to separate the room into each of those individual spaces. People think about rooms in a building lots of different ways. The fire department might be interested in what fire protection zone a specific room is in, while the people who maintain the building might be interested in the HVAC designation of a particular room. Others, like the management of the tenants in the building, might only be interested in the occupancy information. Security personnel might be interested in the circulation requirements or circulation restrictions of a given set of spaces. All of these are defined in the Cobie Zone worksheet. The next set of information provided by the designer describes the equipment that's installed in the building. An equipment is organized into the type of equipment, the specific components that are installed, and the organization of those components into systems. Next, we'll take a look at the worksheets describing this set of Cobie information. The equipment and products that are installed in the building are defined by type. You can find this type information directly in the design schedules, and that's its actual origin. From the schedules, the design software exports that data and provides it in the Cobie type worksheet. The Cobie component worksheet contains every instance of those installed types. In many cases, design schedules will specifically identify each individual component by name. In some cases, components are identified by type only and noted where each one is located. In those instances, design software should automatically generate unique names for each of the individual components. Of course, not all of this information is provided by the designer. The builder will put in the serial number and the installation date and the warranty date based on the outline provided by the designer. Equipment is also organized into systems. The Cobie system worksheet allows each individual component to be identified as to its function within the building. The contractor provides information about the specific manufacturer and model number and warranty information associated with the type worksheet, and also provides the installation date and serial numbers in the component worksheet. There are 3 worksheets, however, that the contractor is directly responsible for: the job, the resource, and the spare worksheets. The Cobie spare worksheet allows the contractor to deliver the required information about replacement and on-site spare parts, consumables, and lubricants. The Cobie resource worksheet identifies the materials, tools, and training necessary for preventive maintenance and other kinds of tasks to be accomplished. The Cobie jobs worksheet allows the contractor to identify the preventive maintenance schedules, inspection requirements, startup and shutdown instructions, and any other kinds of requirements for regularly scheduled activities identified in the contract. The level of detail of each of these kinds of jobs can be defined in several different ways. One line item, for example, could represent a complete set of information found in a separate PDF document. As a middle ground, the description of a specific job could be included in the description of the jobs worksheet. Finally, if a job requires multiple operations, each of those individual operations could even be represented in the Cobie jobs worksheet. Most projects will also include information in 3 of the common worksheets. Let's take a look at these now. The first is the contact worksheet, and the contact worksheet is really a catch-all kind of set of information. It contains information about the author of all of the data in Cobie. Also, it contains the list of the manufacturers, warranty providers, and spare parts suppliers that you might reference other places. Putting them in the contact worksheet allows you to centralize the development of this information and reuse it throughout the rest of the Cobie file. You can think about Cobie as a smart outline that contains some minimal information about the specifics of the assets in the buildings. A lot of the information is still locked up in document files. Documents can be attached with the Cobie file and referenced in the Documents worksheet. The Cobie Attribute worksheet contains the attributes of any of the other worksheets in Cobie. So, the properties of room data sheets, they're here in the Attribute worksheet. The properties of equipment schedules, they're also here. Anytime you have any properties and there's no other place to put them, they go in the Cobie Attribute worksheet. I hope you found this video useful in understanding the structure of the spreadsheet version of Cobie data. Thanks for joining me today.
In design and construction projects, the ultimate purpose of Cobie is to deliver the information about the assets in a facility to the next owner or manager. At the end of the phase of the project life cycle, typically this is the owner at the end of the construction. But it can also be applied to an intermediate handover between consultants during the design or the construction process. This handover might not include all the information ultimately required, but it can provide valuable pieces of that information to assist other consultants. These are called interim deliverables. These are sometimes called data drops and are also valuable to allow the project team to build up the process and information ultimately needed by the end of the phase to help to ensure the final handover. Even though the interim requirements are not required for all projects utilizing Cobie, they are strongly recommended, especially for larger projects. Common milestones where it will be beneficial to include a data drop are the end of a conceptual design, the end of this design development, the end of the construction documentation, and at fixed intervals during the in-use phase of a facility. The minimum requirement for a Cobie deliverable is to populate the required fields in the required tables. Any additional table and fields must be specified that are required by the person or company who will provide the Cobie deliverable. Also specify who will manage and transfer the Cobie deliverables and each phase to ensure proper coordination between phases. What tables and fields to select depends on the desired use of the Cobie deliverable and each phase, but it is recommended to start with the end in mind. Each deliverable depends on the phase. You can be on the design phase, you can talk about space, the system, the equipment, layout. When you are on the build phase, you can talk about product data, as-built layout, any tags, serial number, warranties, and spares. So when you have the operation of the building, you have those data. Cobie has required fields statuses for most tables, and some fields are prerequisite to use the subsequent tables. The reference and if specified field statuses are prescriptive once the required fields are completed of each table. A list of required reference and if required field statuses are in the structure section. When using tables and fields to use for a project, specify how much information is necessary for each type of equipment, because it may not be useful to collect Cobie data for all equipment and build equipment, for example. It may not be useful to spend the effort collecting the serial number for every light fixture if the policy is to replace it with a similar type when it is unrepairable. However, it may be necessary to collect the serial number for equipment with long warranty duration to assist at filling a possible future claim. Case considerations. The scope of a construction project can be small, such as changing a filter in a building, or enormous, such as constructing a 12-mile-long subway. Construction projects are temporary endeavors that take place over time and are composed of phases. The Construction Specification Institute, or CSI, recommends 9 phases and defines them in OmniClass Table 31, dated on 30th October of 2012, and you can find this on the OmniClass webpage, omniclass.org. This CSI lists the phases in order of a traditional construction project cycle. However, work activities may occur in more than one phase simultaneously. For example, the design phase may be revisited to modify construction drawings due to unforeseen conditions while the remaining work continues in the implementation phase. In this example, an update may be required from the people responsible for the design phase and the people responsible for the implementation phase. The table below, on the next slide I'm going to show you, indicates which Cobie tables will likely be updated at each phase of construction, and the following is a guide to help select which fields to update at each phase. Well, on this table we can see a correlation between the tables and the table groups that we can use with Cobie, and when can we apply this on the different construction phases. So for example, if we see the general table groups will be the company information, this applies to all the construction phases. When we go to the space table groups, we can apply this on the conceptualization phase, on criteria definition phase, and on the design phase. Also on the handover and on the closure phase. As you can see on the closure phase, we have all the tables that should be completed. And while we go further on our project, we go on different phases. We go and we add the information of the project. If we go to the product table groups, this starts on the design phase and finish on the closure. Goes all the way on the coordination, implementation, handover, and operation. The operational table groups that talks about the resource, the job, the event, and the package goes on the handover phase and operation phase, all the way to the closure. And you also have supplementary table groups that covers the risk tables, document tables, attributes, and coordinate tables. As you can see, the document tables are the most important here. Goes mostly all the way that of the on the operation phase. Then you have the attribute table that goes from the design phase to the closure phase, and the coordinate design phase that goes from the design phase to the closure phase. Well, now we're going to talk about the detail of each phase. The inception phase, this is the phase when you establish the project vision and means to satisfy the client business or public service requirement, including site selection, planning considerations, establishment of timeline, method of delivery, budget, and identify the necessary resources, design, legal, financing, insurance, etc. Well, this is also called inception of a project, preparation and brief, strategy, and requirement constraints. During the inception phase, the company and document tables may be updating. The company table requires information in the name, company, and phone fields, and the document table requires information in the name and path fields. Prescribe which of the remaining fields to update for the deliverable within the inception phase. For example, prescribe that the engineering firm develop a project charter and additionally complete the Cobie document table field and the Cobie document table name to capture them as the creators of the document. In this scenario, the document name field is the project charter, the title, and the Cobie document path field is the relative path to the document from the Cobie file location. The Cobie document table field is a company table, and the Cobie document table name field is the engineer's firm name. Also indicate who will review the Cobie deliverable for the inception phase, such as the owner or the internal staff, and who will assume the responsibility of the Cobie data after approval. Well, now let's go to the conceptualization phase. This phase is to identify the major design ideas in the context of programmatic objectives, facility performance, activity parameters, and to define spaces. Also, to initiate basic project element considerations. Well, this phase is also called as concept and outline solution. The company facility level space type and document tables may need updating during this phase. It is recommended to consult the staff when determining what fields to prescribe because it may be necessary to provide more guidance to the person who will perform the updates. For example, the space manager may require the Cobie space room tag field to follow the naming convention. or the Cobie space net area field to conform to a specific measurement standard, such as uh, from the Building Owners and Managers Association, BOMA International. These unique requirements are not part of the Cobie standards, and they will be needed to specify. Indicate who will review the Cobie deliverable and who will assume the responsibility for the Cobie data after. Well, now let's talk about the criteria definition phase. This phase is to create and define the schematic diagrams of the basic project elements, such as substructure, shell, interiors, equipment, services, furnishing, special construction and demolition, and building site work. That will establish project spatial and element criteria as the basis of design. This is also called development and definition. The company facility level, space type, space zones, type, and document tables may need updating during the criteria definition phase. It is recommended to consult with staff when determining what fields to prescribe and check for any additional requirements when capturing Cobie data. For example, the facility manager may only need Cobie data for a few assets such as HVAC units, power transformers, water pumps, etc., and may want the Cobie type warranty description field for all of them. Well, let's talk about the design phase. In this phase, the project is established the means of satisfying project basics of design requirements and technical solutions, and evaluates alternatives through the value analysis and similar processes, and completes. This is also called technical design and construction information. In addition to the tables indicated in the criteria definition phase, and component, system, attribute, and coordinate tables may include updating during the design phase. Consider that values to update in the attribute table for each asset. Now let's go to the implementation phase. This phase is to implement and coordinate the design throughout the construction, planning, prefabrication, and field execution, characterized by constructor means and methods, and controlled by quality assurance and control protocols. This implementation phase is also called construction or the building phase. More detailed information will become available during the implementation phase when the constructor installs equipment, such as the equipment serial numbers, installation dates, precise locations. There may also be product submissions received for review and approval during this phase, such as tables, types, components, documents, and coordinate may be needed updating. Now let's talk about the handover phase. This phase is to evaluate and complete the work throughout testing, inspection, and commissioning activities, including for any owner-furnished equipment, to ensure that the design and the performance criteria are met while conforming the applicable codes and standards, and transfer project knowledge from the design construction team to the owner and facility management team via demonstration, training, and documentation. This is also called the closeout. There may be a need to update some fields in the type, component, and document, attribute, and coordinate tables during the handover phase for various reasons, such as replacing equipment with a different manufacturer due to failing inspection. Information could also be captured that facility managers need to service equipment such as skill type, maintenance and activities, and service schedules in the resource job events and package tables. And finally, let's talk about the closure phase. This phase includes the facility closure, preparation for unknown future use, demolition in whole or part of the project, foreclosure, sale, or similar dispensation initiated by the decision of that facility no longer meets the needs of the owners and cannot be feasible reconfigured to continue the use of that owner. This is also called decommissioning, end of life, and renovation. When you demolish a building in whole or part may result updating essentially all the tables, depending on the project scope. It is recommended that partial demolitions are diligently captured to ensure the Cobie deliverable reflects the built environment for the next project. Well, now we're going to talk about some management consideration. The BIM execution plan for the project should specify which phases a Cobie deliverable is wanted and who will be responsible for updating each field within that deliverable. The National BIM Standard of the United States includes a section on BIM execution planning. For a larger or more complex project, a Cobie execution plan may be needed to define all the owner requirements for Cobie deliverables, including the roles and responsibilities for data management. Well, now let's talk about some successful Cobie implementation plans case studies. We already talked about this project, the University of Texas at Austin. They used Cobie to manage the construction and maintenance of the facilities. They also collected the necessary data, prepared to prepare the Cobie file, validated, delivered to the stakeholders, and maintain it over the time. This helped them to reduce cost and improve efficiency on the operations. The challenges faced on this project was to ensure that all the relevant data and stakeholders were on board and involved in the implementation process, particularly given the size of the complexity of the university facilities. And another challenge was to collect and organize the vast amounts of data required to populate the Cobie file, particularly given the decentralized nature of the university's facilities and management operations. Some of the lessons learned on this implementation was the importance of the stakeholders' engagement and collaboration throughout the implementation process, the need of clear and consistent data standards and management practices, and the importance of ongoing maintenance and updates to ensure the continued accuracy and relevance of the Cobie file. Another successful Cobie implementation plan case study was the Denver International Airport, or the DIA. The DIA used Cobie to manage and maintain its facility data during the major renovation project. They used Cobie data to track equipment, material, labor costs, which helped them save time and money. The use of Cobie also helped improve communications and collaboration among various teams working on the project. Some of the challenges were collecting the data and organizing the necessary data, as it was required for collaboration among multiple teams and departments. Another challenge was validating the Cobie file. This was time consuming and involved reviewing large amounts of data. And the final challenge, or all the different challenges, was maintaining the accuracy and consistency of the Cobie file over the time. This ongoing effort and coordination among multiple stakeholders. Well, and the lessons learned from this Cobie implementation on the Denver International Airport was the using Cobie helped them save time and money, tracking equipment, materials, and labor costs. Cobie improved communication and collaboration on the project team, and using Cobie helped the DIA maintain an accurate and consistent data during the major innovation project, and also on the facility management phase. Well, finally, if we can have some recommendation from this project was if you start the Cobie implementation plan early in the project, it will allow you to have um, accurate data collection and validation. Also, ensure that all the stakeholders are aware of the importance of maintaining an accurate and consistent data in the Cobie file. Consider using automated tools to validate and maintain the Cobie file over time, and provide training and support for stakeholders to ensure that they are able to use the Cobie file effectively. Well, and now talk about final successful Cobie implementation plan case study. We're going to talk about the Royal Society for Protection of Birds, or RSPB. The RSPB used Cobie to manage the construction and maintenance of its nature reserve. They collected necessary data, prepared the Cobie file, validated, delivered it to stakeholders, and maintained it over the time. This helped them reduce cost and improve efficiency of their operations. The challenges on this project were the lack of standardized data. The RSPB faced challenges in collecting and collating data from different sources as the data was not standardized. Another challenge was the integration of different systems. Integrating data from different systems into a single Cobie file was a challenge that the RSPB had to overcome. Another one was the resource allocation. Allocating enough resources to the project, including personnel and funding, was a challenge that the RSPB had to overcome. And finally, another challenge was to maintain the Cobie file. It was important to continually maintain the Cobie file by updating it regularly to ensure that it remained effective and managing the facilities. Some of the lessons learned from this project was a clear scope definition is critical. The collaborative effort is important also. The success of the project was dependent on the collaboration of the team working on the project, including the design, construction, and maintenance teams. The data accuracy, collecting accurate data was crucial in ensuring that Cobie file was effective in managing the facilities. And finally, the proper training was important to train staff on the use of Cobie software to ensure that they could input and retrieve data accurately. Well, now let's talk about some steps that you can follow to create a Cobie implementation plan. The first one will be to define the project requirements. Before you begin implementing the Cobie standards, you have to understand the specific project requirements. This includes identifying stakeholders who will be using the data and the information they need. You should also determine the level of detail required for each component of the building. Another step will be to identify the data sources. Once you have defined your project requirements, you need to identify the data sources of each component. This may include BIM models, CAD drawings, manufacturer data sheets, and other sources. The next step will be to create a data management plan to ensure that the data is accurate and updated. You will need to create a data management plan to outline how the data will be collected, verified, and updated. The next step will be to choose a Cobie software. There's several Cobie softwares available to create and manage your Cobie data. You will need to choose a tool that fits your project requirements and budget. Another important step will be to train your team. Once you have chosen the software, you will need to train the team in how to use it effectively. This includes training on data entry, validation, and data exchange protocols. It is important that everyone involved in the project understands the purpose of Cobie and how it will be used. And finally, another step will be to develop a workflow. Once your team is trained, you will need to develop a workflow that outlines the process of generating, validating, and sharing Cobie data. This includes a clear definition of roles and responsibilities, as well as protocols for data exchange and communication. Here are some final steps just for controlling the data. We always have to test and validate the data. This may involve reviewing the data for completeness and accuracy, as well as testing data exchange protocols. We also have another step that we have to implement and maintain the data. Once it's validated, it can be implemented for the project. And this is important to continue to maintain the data set throughout the project, ensuring that it's kept up to date and accurate. Another step will be to review and refine. As the project progresses, it may be necessary to review and refine the Cobie implementation plan. This may involve making adjustments to the data management protocols, updating the Cobie data set, or revising workflows based on feedback from stakeholders. Well, to close this video, this chapter, we're going to do an online exercise on how to develop a Cobie implementation plan. You can select a project of your interest to develop the Cobie implementation plan and follow the steps. First, use the definition of the project requirements, identify the data sources, data management plan, select the Cobie software, training plan for the team members, develop a workflow, testing and validation of data, implementation and maintenance of the Cobie dataset, and review and refinement of the Cobie implementation plan. You can add this on a Word document and consider all the information that I give you. Use the template of the Cobie standard and select all the tables that you required on the different phases that you are working on. So let's see how you do with your Cobie implementation plan. We can review your project and we can talk about what you have. If you have any questions, just let me know. And to finish this video, we're going to talk about the Cobie implementation, why it's important. It is an important aspect of the building design and construction. It enables the efficient and accurate transfer of building information from the design phase to the construction phase and beyond. By implementing Cobie, stakeholders can manage better the building lifecycle, reduce errors, and improve collaboration and increase productivity. The Cobie implementation plan should be tailored to the specific requirements to the project with a focus on data management, software selection, team training, workflow development, data testing, and ongoing maintenance. Please follow the steps to create your implementation plan, share it with the team, and we're going to talk about your plan and how, if it's correct or if we can modify something. Just let me know, and we'll see you on the next video.